Hello, everyone. Welcome to the online live event series, The Path Forward, Scaling AI and Data Science. My name is Julianna DeLua, and on behalf of IBM and IBM partners, we are excited to have you all and look forward to today's session. So this is part 2 of part 5 series, 5-part series about retired technical debt and open up data science for all. And we have some great guest speakers today, just like we had last time. Prolifics is IBM business partner, and they have extensive implementation experience, and that's the reason that we tap them to really talk about what's going on in our client's mind about technical debt, the impact, and how do we replatform, and then being able to bring all the participants, including contributors, stakeholders, and others, into a platform. Michael Gonzales, Dr. Gonzales, PhD, is the Chief Data Scientist at Prolifics, and he will take you through some of the technical details. After John Radi, he's the Global Sales Leader of Prolifics, and he's going to give you a little bit more about the up-to-date insight of our clients. And just as usual, this webinar is conducted fully live. We'll have some polling a little bit later on, and you can ask us questions anytime. There's a panel of experts waiting for your questions. Now, when you look at the console builder, your console, to the left, you see today's presentation in PDF. You can also download Prolific Agile Migration Paper and visit Prolific site, Analytics Practice as well. And then you have the link to my blog, Read 5 Ideas for Accelerating Data Science and AI Innovations, and Force the Total Economic Impact of Explainable AI. This is really interesting. How do we quantify the value of bringing monitoring models and the governance of models? You can also review, we just refreshed the Gartner Model Ops newsletters that includes IBM Position on Model Ops, and two fresh new research that would be complementary to what we are discussing throughout the series. And you can also download the Forrester Wave on predictive analytics and machine learning solutions, and IDC Advanced Machine Learning Marketscape as well. This is how you can read a lot more about what's evolving in the market, as well as our leadership. And so let's get started here. So I want to start out with why we really thought this particular topic was interesting at this point, and especially replatforming the new normal. The book by Jeffrey Parker, Marshall, Alston, and these are the researchers from MIT. And they wrote about the platform revolution, and businesses really accelerated platform adoption for these benefits. These are the foundation, fundamental benefits for platforming. So that's networked economy, much more modern architecture to really incorporate some of the new innovations that are happening. And also you can increase efficiency among all participants that we mentioned earlier. And as many of you have experienced, there's a huge disruption that happened last year, but also there are tremendous opportunities. This forced migration to a lot of these things digital, in some cases overnight. And the leaders are leaping ahead, bringing skills, architecture, and platform into a modern era. And new class of innovation is happening as well. And in our case, we have brought in some of the analysts, people who might not have coded. It's kind of one area that Dr. Gonzales is going to talk a little bit more with the SPSS modeler. But in addition, there's tremendous excitement about bringing in developers into data science. And we're going to cover this a little bit later in the series, but AI developer basically bringing in the great developer communities into the AI platform, and they will be part of data science using Python and R and so forth. And as part of that process, we're also removing the impediments from the legacy tooling. And it's not either or. You can manage disruptions while saving risk and cost. But as many of us know, paying off technical debt is very hard. So if you look at the recent research by McKinsey, what is technical debt? Why does it matter? So it's really the accrual of some of the technology, I mean, different ages, right? Some companies might be dealing with, decades of old technology, just something that had to be done. Some of the newer companies might not have to do it today, but as things progress, unless you have a methodology to continually update the data and some of the outdated technologies, the impact is really significant. So this research shows that CIOs believe technical debt is increasing, but generally allocate less than 20% of the tech budget to paying it down because there's so much going on. You want to build new features, you want to serve the clients better, build apps. Those are very exciting things, but this tend to slow us down. And interesting enough, this particular period in this past year, that because some of those activities that are customer facing might have to be halted, it had the opportunity for us to rethink how do we resolve some of these technical debt. So if you look at the market research from Gartner, for example, the automation is a key by 2025. 50% of data scientist activities will be automated by AI to ease the acute talent shortage. And the second one that talks about, depending on the research, but I'm always hearing about 80% is not something significantly value add, it's repetitive tasks. And that include data preparation and feature engineering. Those are the pain points. So if you think about, technical debt, we want to address these pains while migrating off from the legacy tooling, and uniting these teams with varying skill sets are crucial. Another research, I'm sure many of your environments have different clouds. It could be AWS, Google, Azure, IBM. So we want to bring some of these models into where data is with the gravity and some of the regulations that require the data to be there. And obviously, we're not just automating for automating's sake. We really want to have the blend of automation and human insights. So that's kind of what we're preparing for. So the Cloud Pak for Data really has the AI lifecycle as part of the core foundation to help build operationalize AI delivery, and being able to minimize some of these mundane steps, and the governance ability to ensure model quality is crucial. So that's the key aspect of being able to handle this end to end. We're going to talk a little bit more use cases later on in the series, but when you have the platform, you can start with one use case that's pressing. You deal with some of the technical debt. You can also use the same platform for new POCs and others. And here's the way you can think about it from the customer experience perspective, lifecycle automation. And the Watson Studio Premium is the one that has the visual data science and decision optimization. So bringing everything together to be able to do this in any cloud. So I wanted to just have this as a few offers as we progressed in today's session. The first one is the Watson Studio Premium Modernization Upgrade. We've been running this since last year, but to address some of you who may already have CPLEX and SPSS modeler licenses from IBM. These are very crucial technologies for many clients who have relied on decision optimization and visual data science. So we have a package to address both modernization and the legacy migration needs. And you can contact me later on if you want to learn more about that. But the value really is to be able to build on your success with what you have from IBM tooling perspective, SPSS modeler and decision optimization. And you can retain and migrate some of your environments and transform at your own pace. And there's a lot of additional value add that you can bring it into table. As I was mentioning earlier, it's not either or. You can actually gain benefits, immediate benefits, by progressing into the platform. One of the researches we've done with Forrester is to have the 1.2 to 3.4 million in terms of the additional data science and AI benefits. And because you're migrating, you can gain the containerization efficiency. I mean, that could be tens of millions of dollars. And this tend to be one of the ways you can make a business case. The visual modeling side of it, and that's our capability, is a part of Cloud Pak for data, and then that can produce as high as 40% efficiency. And decision optimization piece, which really, in our case, combine the predictive insights and then act on that particular insights, and that ROI is significant. So if you just do the prediction, it's great, you can gain insights, but then now how do you schedule your technicians, or how do you create the right workflows? So just to reiterate the benefits of moving forward in terms of retiring technical debt and the replatforming. So this is just another example for retail that you can look at the historical transactions from the predictive analytics perspective. What is the expected demand looking like? And this, obviously, the entire thing was disrupted. The type of goods that clients are buying, if you're retail or other verticals, the demand, it has been disrupted. There's different types of demand, like people who might have been buying more of a leisure goods, they could be buying the essentials. So those predictive demands that go into the insight, and then from the optimization perspective, you can optimize the inventory, looking at the routing, making sure the right fleet would handle that, and negotiate with suppliers. In many cases, our clients change the supply chains to address some of the needs, bring back something onshore and so forth. So those are the examples, again, from a use case perspective, that's exciting to consider. So I want to take a poll. How important is addressing the technical that impacts data science and AI projects today? So you can answer very important, slightly important, not important. So I'm going to give a few more seconds so you can answer this question. Okay. So it looks pretty significant, very important and important. Obviously, because of the title, we attracted the groups of people that are in these two camps, and not important, there's zero. So this is something that we expect you to think of this as you attend this webinar. So now, poll number 2, are you currently executing or planning replatforming project today? So that includes maybe migrating off of legacy tooling or bringing existing one all together, consolidation type of thing. But if you're really considering the platform, you can answer this, right? Yes, we're at a planning stage. Yes, we're in the midst of replatforming and execution. Or some of you might be just really ahead of the camp. Yes, we're finishing up or have finished. Or number 4 is no, we do not have a replatforming project today. Okay, so good. So I guess there's a lot of interest in this topic. So you learn how with going through the next section, and there's a lot that you can gain from. I guess 90+% of the participants today will be excited to hear from this. And obviously, if you already finished the rare 2.1%, there's something for you to learn from. With that, I would like to hand it over to John.
Thank you, Juliana. Hello, everyone. My name is John Radi. I'm Global Sales Leader for Prolifics. And what I'd like to do is just take a couple of minutes to introduce you to Prolifics and just talk a little bit about who we are. So Prolifics is a global solutions provider, and we have a global presence with offices all over the world. We've been in business since the mid-'70s. We've been an IBM partner actually for about 2 decades, and have won numerous awards with our partnership in conjunction with IBM. A couple of things to note: we have a 91% repeat customer engagement score, and we also have a lot of technology accelerators and IP that we bring to a lot of our projects. Many certifications. As well as several IBM champions on our staff. So one of the things that makes us unique is that we have what's called our Innovation Center. And I kind of liken this to, think about it almost like a client playground. And what it does, it actually allows for consulting and engineering collaboration with our clients. To explore use cases of different varieties. We bring leadership and value to our clients around the Innovation Center. But I think most importantly, we provide strategy to our clients that engage with us around the Innovation Center. So we again, it's fairly unique. We help clients create the vision and provide value around what they're thinking about. So we offer a variety of solution types and services. In addition to IBM, we're also Red Hat Apex partners. And we have a great deal of experience around OpenShift, both on-prem, if clients are running it on-prem, or in the cloud. We're also an IBM Global Elite partner in the information architecture space, in the data and analytics space. And we offer a variety of service delivery options, both from an onshore model, an offshore model, or even a hybrid model. As mentioned on the previous slide, really at the core of our information architecture practice, we can provide a variety of solution and support options. Today, we're really going to be focused on the 2 pillars on the right: agile data science and modernization and migration, and really how leveraging the power of data science and migration modernization and underlying operational intelligence, really at the core, can help provide guidance in eliminating technical debt, both within your organization and within your company. So we help you build out these use cases in a variety of ways. I mean, obviously we can do variety of data strategy workshops around this. We have assessments that we can perform with the client, and so there's a lot of ways that we can deliver some of this value add to our clients. So let's go ahead and get started. And the theme for today's session is attacking technical debt to unblock innovation. Now, Peter Drucker, who many think or consider the godfather of practical foundations of modern business, said, if you can't measure it, you can't manage it. And so I always like to start off with a little humor. And as you look at this, all kidding aside, at the end of the day, if you can't measure it, you can't manage it. And inevitably, it's definitely just going to be a guess. So often, when I talk about technical debt, I like to refer to Martin Fowler's technical debt quadrant. And he really likened technical debt to almost a metaphor, whereas, reckless code and inadvertent decisions within the organization can cause technical debt. And in this case, as it relates to software development, it implies the cost of rework, thinking, if we rework this, it may represent a shorter time to value. But in the end, it's really racking up more technical debt without even realizing it. And so we ask customers and clients to think about these questions when exploring, hey, how do I get rid of technical debt? How do I eliminate it? How do I quantify it? How do I measure it? And so some of these questions are pretty relevant. We ask these questions in some workshops and assessments that we do. But how are you quantifying what may be in an environment, or how do you keep technical debt from interfering with innovation around data science and advanced analytic within your organization, or how do you gauge yourself in the journey of reducing technical debt? So there's a variety of different questions that we like to answer and have conversations with our clients. So I can't help myself. Here's a little more humor, and some of these words on the slide are a bit strong. However, for those of you on the call today exploring this, you may have felt some of this. Hopefully not, but you may have felt some of this. Like, hey, there's still a lot of project work to be done. Oh, that's not technical debt. That's just our to-do list. Or these deployments are fine. They take us 48 hours straight over the weekend. Or actually recognition where, hey, on closer inspection, we appear to be displaying some of these symptoms of full-on technical debt. Or, okay, hey, let's face it, we're kind of drowning in this. Let's go fix it. Let's go figure out what we need to do about it. And lastly, there was a survey done by one of the leading analysts around managing technical debt. And this is what some of the I&O leaders came back with. And so when they looked at reducing technical debt, they wanted outcomes such as faster time to market, or creating an innovation mindset amongst our core crew. Providing modernization and business resilience and availability, flexibility, security, compliance, all of those things. But they wanted to be smart about this, and they wanted to attract, certain competency skills, and certainly stay relevant within their business stakeholders, their shareholders, and their clients. So what I'd like to do now is turn this over to Dr. Michael Gonzales, just to walk us through a particular use case and kind of where all of this fits as we're talking about reducing technical debt in the advent of analytics. And Mike, I'll turn it over to you.
Thank you, John. I'm going to start with just kind of a summary. Some of what Julianna said and what John had already communicated. There's plenty of evidence already that suggests that, you want to look, one of the key aspects or one of the critical components of what a modern architecture needs to reflect is that you really want to look for in data science and machine learning, right? So we're really looking to try to chase a couple of things here. We want to employ open source technologies for our data science or machine learning. And I would take data science even in a broader perspective and maybe include in that same discussion anything that you're doing in BI or you know, the typical type of BI analysis and standard reporting. Augmented data science and machine learning to make it more available between the experts in data science so that they and the citizen data scientists or they and the subject matter experts in business, they can collaborate a lot more effectively. And so that's another element of what is envisioned as necessary elements going forward in a modern architecture. And then it's the idea of being able to create this virtual teams, right? So we're looking to integrate open source technologies. We're looking to augment and enable our citizen data scientists and our data scientists, and we're looking for collaboration. All of that is just kind of best practices now, or at least it should be for everybody to recognize. And I want to draw the attention of these types of characteristics to a real type of use case that we're dealing with. So let's take a legacy example. In this case, it's SAS 9.x on-prem. You know, this is a large environment, not different than many large organizations. They'll have potentially several different advanced analytic technologies that they've implemented over the course of time. So you have a smattering of a lot of different vendors that are affecting your organization. And SAS, you know, is one of those vendors that will show up in organizations with a lot of on-prem muscle. And it's reflected in large platforms. And these platforms end up being, over the years, you know, some of them are, you know, 10, 15 years old. These types of platforms are essentially a breeding ground for brittle applications, right? In other words, a brittle application is an application that's highly tuned to the platform. In other words, it's been debugged, it's been optimized, you know, exactly to that ecosystem that it lives in. Consequently, if you touch it and try to move it, it's going to break. So it's brittle simply because it's so overly tuned. It's hardened to that particular platform. And in this case, for one of our clients, that certainly is true. This platform has been there for several years, and it's got the whole contingency of SaaS professionals that have grown up around SaaS procs. So it is definitely indicative of a platform that is suffering from technical debt in the sense that it isn't a modern architecture, it isn't in the cloud. There's a lot of issues. In this particular case, it's an advanced analytics platform, but more often used for BI than advanced analytics. So, you know, we recognize the importance of BI, obviously, but when you invest in this kind of technology, you're expecting a lot of heavyweight data science type of initiatives going on and applications going on. But here, what we have is a platform that's not only mostly used for BI, but the majority of code that's written out there is really ETL and data wrangling. So when you think about it, you've got a very expensive platform that you've invested in over years, but over that time frame, there is a less percentage of overall programs actually supporting the value of data science, the advanced analytics, for which you originally intended this platform to be, and mostly supporting data wrangling, propagation of data, and standardized BI reporting and analysis. So there is a significant amount of technical debt in this particular case. So when you look at, when you compare that kind of on-prem scenario with what a cloud-based modern platform would provide, number one thing is that I mentioned up at the top was employ open source technologies. Well, all of the modern big players in cloud-based architecture just are really founded on open source, right? So you're looking at PySpark, you're looking at Python, R. You have a lot more of an embrace of the the data lake concepts and Hadoop. So there's a big opportunity for open source that is essentially native to the leading cloud-based platforms. Another important point is that oftentimes these on-prem platforms have evolved over time, and their application, basically has changed. Maybe, the rationale, the original rationale for implementing it may not be what is finally evolved into. And if you are going to use a relatively expensive and advanced analytics platform for mostly BI, standard reporting and analysis, then there are much better, literally better tools and cheaper platforms out there for BI. I mean, much better. So that's another opportunity to resolve some technical debt. And it's not just the expense of this on-prem environment, but it's actually doing more for less. And the final point here is that, these on-prem environments oftentimes have evolved over several years, and you end up with a lot of different owners, people that have churned through the different teams that are on these platforms. And, they keep on adding a little bit here, a little bit there. It's like, it was a small house at one time, and then they did a remodel and added a room, and then they added a garage, and then they decided to connect the garage to the house. I mean, it just looks like a cobble of stuff. And that's essentially what happens in this particular case, where the majority of code that's running out there is literally data wrangling and ETL. But moreover, it's actually manually kind of executed, right? So, Carl comes in and runs his set of code to update certain tables, and then Sally comes in and runs her whatever code and, whatever processes that she's established to source and propagate the data so that the SaaS environment can take advantage of it. So there's really no formal, structured, scheduled execution of the data propagation and sourcing. But that happens to be one of the biggest benefits, and there's several, but this happens to be one of the biggest benefits on cloud-based architecture, is that whole end-to-end of dev operations, right? Where I can source, I can propagate data through a variety of different data storage targets, and I can even execute, some machine learning and push out reports. I can literally automate that entire pipeline. And frankly, it's a big challenge for us to think in terms of data pipelines or an automation, but going forward, that's just going to be a critical point of competitiveness, being able to automate these kind of processes. And that fundamentally is what's available in modern cloud-based architectures. So what Prolifics has is a methodology that is really based on providing a more business-sensitive approach to migrating or modernizing. In other words, we want to help business. We want to help the IT entice business to make that move over to a modern architecture. We find that the approach to migration is probably the least effective is telling all of business, especially in a large organization, you need to get off of this platform in 18 months because we're done with it. And that's, while that might have to happen from time to time, that's not really, I don't think, the best approach, nor have we wanted to ever recommend or advise that that's the best approach for our clients. Instead, we really take a business-centric, a business sensitivity approach so that we can migrate business or user communities in where they're actually happy to get on the new platform, or at least, at the very least, understand the rationale for getting on the platform. So our framework is really based upon planning, education, assessment, and migration, right? So those are the key dimensions that we leverage or help our clients leverage this migration effort. And if I had to boil it down, I would say that this at a high level, and it's just a high level image, there is a lot of detail that needs to go behind this, right? And we also recognize that migration is not done as an isolated event. We oftentimes have to work with other areas in an organization that have either initiated a data migration or are in the process or are responsible for the data migration to a modern platform. We often have to coordinate activities and collaborate with a governance initiative. So we recognize that there's a lot of other elements that are necessary to migration. But one of the key elements that we like to make sure that our clients understand is that we make every effort to provide more than one way to migrate. So you'll find organizations oftentimes only focusing on one way to migrate. And that's really the replace option, right? There's like 7 different levels, nuances of migration strategies. But we've really settled on these 3, replatform, refactor, and replace. And replacement is obviously the easiest one to understand. It's also the most expensive and the most risky, but it's easy to understand. We're going to just make it a whole software development effort. So in the case of SaaS, we take your SaaS code and we fully develop highly optimized PySpark or Python code on the target cloud-based platform. So the mistake, and it's not prolific saying it's a mistake, industry-wide as best practices, the mistake is to think that all migration needs to be done by replacement. And the reason that that's a mistake is that there's plenty of legacy applications that can lend themselves to optional ways to migrate that are less expensive, less time consuming. So replacement, we believe that if we're going to do it, we should be doing it with an idea towards design thinking. In other words, let's really innovate. If we're going to go through the religious experience of redeveloping everything, well, let's help business think out of the box, make sure they fully appreciate that target platform we're going to, and modernize, optimize, and innovate. That's what design thinking is all about. So if we're going to go through the replacement, let's make sure that we're really emphasizing modernization, optimization, and innovation. However, the other 2 options are going to attract a lot of opportunity. Replatforming is literally running your same application in a different runtime, right? So I'm going to take whatever I've got in my legacy system, I'm going to put it on a cloud-based architecture. I'm not changing non-functional and I'm not changing functional requirements. I'm just basically using it on a different runtime. And I'm going to show you a perfect example of that. Replatforming let me just go back. Refactoring is another deeper level of migration than replatforming. In refactoring, what we're doing is changing the underlying code. So in the SAS community example, I'm going to take SAS and I'm going to convert it to Python. And Python being an embraced open source language on any leading cloud-based architecture is absolutely welcomed, right? You've got your Jupyter notebooks, you've got Databricks, you've got any number of ways to execute Python up in a cloud-based architecture. But I'm not going to worry about optimizing my Python code, nor am I really going to expand or change the functional requirements. It'll generally behave the same way, and it's not necessarily optimized for the target platform. But it gets over quickly, and we're at least one step closer to actually fully embracing the cloud-based platform, because now we're running at least on an open source language that the cloud platform is integrated with. Those two options, replatforming and refactoring, don't necessarily have to be ends in themselves. What they can be is interim steps to get business onto the modern platform. Maybe a user community just wants to be great corporate citizens. They're going to support this migration effort because they are good citizens, but they don't want and don't have the time, they don't have the budget to mess around with any redevelopment. So it's a great opportunity with replatforming and refactoring to get them onto the new platform as painlessly as possible. The other thing that both of these provide is an opportunity for POCs, or minimum viable products, where I can execute a quick POC on a limited number of programs, put it into that modern target architecture that you want, and let the user community that's supported by those programs, let them explore that modern architecture, let them understand how they might interact with it. So there are fantastic ways to do POCs and minimum viable products quickly. So that's really, we try to emphasize these two. And the reason for these two is not only because they're best practices, but they're best practices because they are more business sensitive. It is not a technical gaggle of geeks effort just to hack out all the best Python code you can and rethink everything. Maybe that's a strategy you have in mind, but we oftentimes think that there's other options, and likely most of your legacy would probably fit within these first two options of migration versus the full replacement. So it's just something to think about. So now I'm going to take you through a couple of examples. First, I've got my Watson Studio up there, and I'm going to show that to you in a second. But I'm going to demonstrate the first two migration options that I was describing. Replatforming. In this particular case, I'm going to take a relatively decent sized SPSS model stream that I have on my laptop. Like anybody who's using SPSS Modeler, we love it. It's a great environment. But it doesn't provide all of that cloud-based functionality that I may want to take advantage of. So I'm going to take my SAS stream and I'm just going to move it up to the cloud. Now, I don't have to do anything with that stream other than connect it up to the different data that I want to connect it up once I get up to the cloud. But for the vast majority of my SPSS, for the vast majority of things that you can do in SPSS Modeler, they just get replatformed. In other words, I'm running the exact same stream. I'm just running it now in Watson Studio on the cloud. It's a perfect example of replatforming. The other one that I'm going to do is a refactor example. I'm going to take some basic SAS code. I'm going to convert it to Python. I'm going to cut and paste that Python into my Watson Jupyter notebook and execute it. Now that's a perfect example of refactoring. So let's get to it. I'm going to share my screen, and hopefully everything is still running when we get there. And I'm going to wait to make sure that you folks in the audience are seeing my screen. Yep, that's my screen. All right, so let's take a look at a couple of things. Let's take a look at the replatforming. So I have this SPSS modeling stream sitting on my laptop. And here it is in SPSS Modeler. It's a great tool. I love to use it. I've used SPSS Modeler for years. So, this is the meat and potatoes type of model. I'm doing some data wrangling. I'm doing some feature engineering, and then I'm running a predictive model, right? So it's just, the typical type of thing that we would be horsing around with in SPSS. So I'm going to go up to my Watson Studio. Here is my migration project. I have different assets already up here. Here's my SPSS. I have Python. I have a couple of data sets that I'm going to use. Now, before I migrate anything, I want to point out, once I move a data asset up here, well, it doesn't matter what the asset is. There's plenty of different assets. In my case, I have these types of assets I can add to Watson Studio. Depending on your organization, you can have, a lot of these, right? There's, Watson Assistant, Watson Discovery. There's just all kinds of other data or assets that you can add. But anytime I get an asset up in this particular project, I have an opportunity just to share it with anybody that I want to. So in my organization, Aman is, it's loading right now. Aman happens to be a colleague of mine in India. If I want him to participate in this project, I can give him viewer, editor, or even admin roles to my project. So that's an important part of the collaboration. One of the key elements that we try to focus in on about modernization is really that part about the collaboration. So let's start with the SPSS mining. Now, when you create a model flow, and what I'm going to do is I'm just going to start this over again for you. I'm going to go and I'm going to create a new model or flow. So what it's going to come up with, it's going to, let me just give it a name. Nothing big deal here. I can just give it whatever name. But I may want to import it from a file. So I should have put the name here, but I have the opportunity to create just a blank screen. I have an opportunity to create the stream, the SPSS stream, up in Watson Studio from a file that I have, or I can do it from an example. So in this case, I would just go to wherever my SPSS modeler is, and I can pull up any one of my streams, right? Or from this class, here's that SPSS modeler stream. I'm not going to open it. I just want to make sure, well, I'll open it. Hopefully it'll go quickly. So it's right now reading in the stream. I would click on create, and what you end up with is going to be the same stream that we just uploaded, or that I was just showing you. And there it is. So literally, okay, my notes got a little tossed. I just got a lot of notes on this one screen. But this is my stream. This is the exact same stream. And all I really need to do then is just really attach to whatever the data sources I want to use, right? So if I went to import data asset, I'll cut this guy out. Connect up my new data asset to my stream. I open this up, And really all I'm doing is changing to whatever my data assets I have up here in Watson Studio. So it's come up from my laptop. Now I'm here in Watson Studio. I can click on whatever assets I've brought up, and now I've tied it to my stream. So all I'm doing is really just changing where my source is coming from and anything that I'm spitting out. And that's it. It's literally replatforming. All I'm doing is connecting my sources and my targets. That's it. The entire stream itself runs exactly the same. It's a perfect example of replatforming. So now let's take a look at a different example. So here is my Jupyter Notebook, still open, still operational, perfect. So now I'm going to go to an application where I'm going to take basic SAS code. So this is meat and potatoes SAS, right? And I've included the data set in here just so that we don't spend too much time horsing around, just like we did with SPSS. It's not really that difficult at all, but you know, it just makes it simpler for this demonstration. So I've got my data file here, but really what's important is that these are just meat and potatoes type of proc statements, printing out data. I'm doing proc mean, so I'm actually doing, I'm getting an average score for each one of my students. I'm running some proc SQL to kind of do the data wrangling, you know. So there's really just kind of meat and potatoes stuff that you would expect in a SAS program. And I have a lot of different options that I can actually convert this code to, but I'm going to convert it to pandas. And the code that gets generated, it includes all the libraries that I'm going to need. It creates everything as functions, right? So literally what you have is an opportunity to create an entire library. Right, so it takes all the blocks and creates them into functions. At least this particular example, this particular product does. So I'm going to highlight everything. I'm going to copy it all, and I'm going to go back to my Jupyter Notebook. Now, there's prettier ways to do this. That same process, I can create the Jupyter Notebook and just simply import the Jupyter Notebook, and all the cells are nicely laid out and all that fun stuff. But just for our purposes, I'm just going to do a Control-V. Here's that SAS code converted into Python, and I'm going to go all the way up to the top. You see all the libraries that I need. There's one library that I need called Panda SQL. I don't have that installed, so I've just put this extra statement up here to do that, so we can run that guy. Oh, it ran it all. Sorry about that, I didn't intend to do that. So, all right, that was already satisfied, good. It ran this code. And again, by design, it's put everything into kind of a format that lends itself to a library. So really, all you're ever really doing is running this chunk of code in your regular code, right? This would be all. If you converted it to a library, this is all you would need to run. So let me go to the bottom. This is all you would need to run, and this is the standard output. Perfect example of refactoring. I've taken SAS code, converted it to Python, cut and pasted it into my Watson Studio, and executed the code. Perfect example of replatforming. Now, not all of what we do, unfortunately, is going to be as clean, but this gives you an example of the landscape of possibilities. There are plenty of programs and applications sitting in a legacy system that could lend themselves to other techniques of rehosting or migrating beyond just hacking out all of the code, right? And that's the whole point of this. And the whole point of our recommendations to client is to obviously explore, based on what legacy system that you're trying to go chase after, try to explore multiple ways to do the migration. All of them will reduce technical debt. All of them, all of the migration paths, whether it's replatform, refactoring, or replacing, they'll all reduce technical debt. But a couple of those options, like replatforming and refactoring, can reduce technical debt and do it inexpensively, in a less painful manner. So with that, I'm going to pass it over back to John.
Thank you, Mike. That was awesome. So everyone, as a reminder, you can download the presentation content as well as the Prolifix Agile Methodology white paper. You can find that in the council. And now, what we'd like to offer for your attendance today, we're offering a free half-day workshop called a Data Science Triage with none other than Dr. Michael Gonzales. If you're interested in just kind of running, my vision for data science, help me kind of understand what that needs to look like in my organization based on your industry, or, hey, I have a perceived technical debt issue, but I want to kind of run that past Mike, and just think of it as kind of a workshop, a triage. You can certainly email me or visit our website, and we can get you on the schedule for this. Much appreciated. So I want to thank everybody, and I would like to turn this back over to Julianna.
Yeah, thanks all for participating today. Just wanted to touch on a few topics before we conclude this session. So the first thing that pops up a lot is that that even though organization really wants to proceed in replatforming, there are impediments coming in your way. So what are the major challenges in replatforming? Mike, if you could answer that.
Sure, Juliana. So I'm assuming that replatforming here is not just migration. It's a specific type of migration. Is that correct? If it is, I guess, if it is replatforming as a migration option, from a data science perspective, one of the things that you can encounter is the advanced algorithms that are used. You oftentimes have to consider them separately on your target platform. And there's a good many reasons why. One is that there might be multiple options to execute classification models or any of the predictive models up in a cloud platform, and it's important for the data scientists to make distinctions between which models that they do want to run once it's migrated. The other thing to consider is that in legacy systems, oftentimes the execution is not MPP, and up in the cloud it absolutely is, and that could the way that these advanced algorithms execute in parallel, what would happen is it's possible that you have to monitor what the result ends up being. So there are some unique cases when you're looking at replatforming data science specific algorithms.
Anything, John, from your point to add?
Yeah, I mean, one of the challenges that I see a lot with replatforming, just from an organizational perspective, is just the data governance aspect of this, right, and the lineage aspect, and how customers and clients are really trying to get their arms wrapped around, the people and the process part of this, and so when an organization decides to proceed with a work effort like this, I mean, we like to try to have some of those answers as well, just to kind of understand, hey, where is how do we unwind this, and how do we make sure that this is a successful event? And certainly the people and the process and the data governance as a whole do come into play when you're taking a look at a project like this.
Great. So I think Mike will touch a little bit about the data science project. The idea here is that we don't want data science projects to be outside of data mobile, collect, organizing data ops, or just accessing to the databases. We want everything to be on the same platform. But if you notice some, things or characteristics to watch out for in data science, Michael, if you want to address that a little bit, or what to watch out for and what's different about data science projects.
Absolutely. All of the modern cloud-based platforms are really emphasizing machine learning operations, and that's a subset of DevOps. And combined, what we're really chasing is continuous improvement, continuous development. So it changes how we want to execute our data science specific type of processes. We want to be able to monitor them so that we're making sure that any data drift, as an example, that might affect the accuracy of my model. We want to monitor the data going into my model. We want to monitor the scoring coming out of it and have thresholds in place where we could automatically adjust the data that's being fed, automatically retrain the data to the new shape of data that's being fed into it. We could also make decisions about if the scoring output is beyond whatever thresholds we've set. We could literally just stop that output from being published until we have until somebody has an opportunity to look at it. Too often times in an on-prem environment, those models really aren't monitored at that precision, and so oftentimes you get a model whose accuracy has degraded over time simply because data does shape and you do experience data drift or any number of reasons, but the accuracy of the model shifts over time and we don't monitor it carefully enough, and consequently we start getting worse and worse type of predictive value out of our models. And it's just simply because on-prem we oftentimes don't carefully monitor. It is what it is. We don't carefully monitor our models, but in a cloud-based modern architecture, that's really an important part of that migration. So for data science projects, we really need to be careful. We want to embrace the ML ops and the DevOps, the continuous improvement, continuous deployment that's available there.
So the last question is about, it's really hard to retire technical debt, but once you start addressing those, what unexpected benefits can you gain through replatforming, Michael?
I mentioned it in the slides part. I think a big benefit that oftentimes needs to be articulated is that replatforming provides us an opportunity for minimum value product and POC. It allows us to help business communities get an isolated bunch of code or application up into the modern architecture and let them start exploring. Let them understand what this new architecture is going to look like and what are the benefits of the new architecture. So a huge benefit of including alternate migration options is that notion of POCs and minimum value products. I think that's just a huge benefit.
Well, great. Thank you. John, anything else out there as far as additional benefits that you've heard?
Yeah, absolutely. And I covered this a little bit on my the survey for the I&O slide that I touched upon. But really, it's mine is consolidation, right? It's taking, as an example, maybe 3 different applications and consolidating into one future-ready unified platform. I mean, what does that do for you? It gives you better availability and collaboration. It gives you more business resilience, faster time to value because you have that collaboration. So I'd say that's a really big benefit as well, Julianna, just to add my 2 cents.
Okay, great. So,
Juliana, there's a couple of questions up in
yeah,
that I
let's
want to
address some of the questions you'd like to address.
Okay, so there's one question about challenging in refactoring of code, especially models, and also from data format changes. You know, as I had mentioned, advanced analytics, if you're really running, you know, predictive models or, you know, any of the, or even exploratory models, doesn't matter, any of those types of modeling activities, you definitely want to pay close attention to that, to what it's going to look like on your target platform and where you want to execute that model. Now, I understand that you have to take extra care to look at how that model is going to execute on your target platform. But the important thing to understand is the vast majority of work is data wrangling to get to that model. So if you're refactoring, you can refactor the vast majority of work, which is really oftentimes just sourcing and data wrangling and getting the data ready. The small piece that you need to consider on a case-by-case basis is that actual execution of the model. So that's for refactoring, that's an important part of it. And data format changes, that really is going to all happen in your hydration of whatever data lake or target you want to go to, or in the case of, say, for instance, like Cloud Pak for data, I can have virtual data access. So my same data that lives somewhere else, I just virtually access that data, so the data format doesn't change at all. So that hopefully that answers that question. I have one other question about the tool. There's a lot of different, there are some good technologies out there. This happens to be a company, this is SAS to Pi, is the tool that I demonstrated. So those are the questions I wanted to answer.
What tool was, yeah, so the question is just to get a little bit into this question, what tool was used to convert the SPSS code to Python in your example? So this one, and there was a SAS to Python example. There's also an approach that we mentioned a little bit about the ODAI, which is great for pretty much anyone, that you can build the model pipelines and you can extract out as a Python as well. And then you can also bring in some of the open source tools to work with SPSS modelers. So there's a variety of approach to take it here.
Good point. Okay. Good point.
Okay, so yeah, so I think we covered this in terms of save cost, save time, and ability to go faster in terms of time to value and being able to govern. And then it's really about our approach to accelerate the digital transformation, right? So you have your customers and outcomes, and you want to take advantage of pools of expertise, not only just IT, like some of these things we talked about, but being able to use the business domain knowledge and being able to serve customers much better while taking advantage of the automation. So we're going to move ahead into the part 3 in a couple of weeks, but just wanted to iterate the Cloud Pak for data as a base service that contains Watson Studio family that includes Studio, machine learning, and OpenScale, some of that explainable AI component, which we'll be covering in more depth in 2 weeks from today. And then also having the Watson Studio Premium, the SPSS modeler that Michael was demonstrating earlier as part of Cloud Pak for data is available as an extension with the offering called Watson Studio Premium. And similarly, we can also extend out with the decision optimization, and that will be covered in more detail in 4 weeks from today. And what we see is the ability to run run AI lifecycle, and then being able to really grow applications and DevOps talent into AI power players. It's the AI engineering that we were going to talk about in part 5 as we wrap up. And you can see this as the entire cycle of getting a lot more from AI. And a couple of analyst companies have acknowledged this. The Forrester Research consider us the leader in both some of the market reach as well as the offering perspective. So you can read up on your console. And Watson Studio is part of these 3 elements from Forrester Research. We are in the leadership in these 3 assets, as well as IDC. The IBM is also positioned on the basis of Watson Anywhere, being able to automate model building, having the trusted AI components, and being able to optimize deployments and optimize actions. So again, feel free to take advantage of those the research on the console builder. With that, I think we are just at time now. Thanks everyone for joining us today, and thank you, Dr. Gonzales and John, to be part of the panel. And we'll meet in 2 weeks to discuss Operate Trusted AI with Model Governance with our partner Appen. And so there'll be another interesting session to really getting into what's here now about data science. With that, Michael, John, anything else to address it?
No, thank you, Juliana.
No, thank you. Yeah, thank you, Juliana. Thank you, everyone. Appreciate the opportunity.
Okay.
Thank you.
Well, great. So this would conclude today's web seminar.